Visible now.
अच्छा, everyone can see the presentation, na?
सर
Yes,
आपको
sir.
सर आपको हमारा आवाज आ रहा है क्या?
हाँ अभी आ रहा है.
ओके ओके ओके.
Okay, so this was the front of the MUX, and this is the back side of the MUX on the.
1.39
Yes.
39. 0.76.
Yes. Okay. So this is what the back side of the MUX looks. All the connections for the MUX is available at the back side only, except the NMS port in the front of the NIM card. All other connections need to be done at the back side of the MUX. So you have the U1 port in the right side top corner. Mute call. You have the U1 ports in the right side top corner. The first row is for port A. The second row is for port B. And the right side is for incoming signal. The left side is for outgoing signal. After that, below that you have the input for the external clock and the NMS port, which is RS-232 or serial port. And below that you have the 48-volt power connections. And on the left side, you have the outputs for the interface channels. From P24 to P32, you have the output for the interface channels. And P23 is reserved for supervisory control and input and supervisory input, as well as other output for other alarms. Okay. So this is basically the wiring for each individual channel card. Each connector has consists of 4 ports. In general, this is the wiring that is required to be done for both voice channels. So you have voice for forward ENM channels. All 6 limbs are used. The first pair is trans, second pair receive, and the third pair ENM. For two-wire, only first pair and third pair is used. So trans receive is both in the first pair, and ENM is in the third pair. For hotline, exchange, and subscriber, only first pair is used for both signaling and voice signals. In case of G703 also, the same wiring needs to be done. The first pair is trans and second pair is receive. Okay, so let us go into the detail of each of the system cards. Of course, the most important 2 cards of the multiplexer are the name card and the tributary card. So as I said, the name card is like the brain of the multiplexer. It stores all the data and makes all the decisions, and it monitors the health of the multiplexer and the signals. Okay. So here you can see the functions of the NIM card are shown. First and foremost, to identify a multiplexer, you have to set the address of the multiplexer in the NIM card itself. So there are two rotary switches. You can set the address from 01 to 99. Okay, there in the NIM card there are two rotary switches, S4 and S5. And when accessing the NIM card through NMS, the NIM card, this address is required to be used. Second is whatever configuration you are doing to the MUX using the NMS, they are all stored in the NIM card. The configuration means the cross connect card parameter, all those things. So one of the important things regarding the NIM card is if you are required to replace the NIM card at any station, you have to once again download all the configurations of the NIM card of the MUX into the NIM card. This is the only card which if you replace, you need to program the MUX once again. Okay, so there are yes. Any questions or comments? Okay. Okay, I'll continue. I'll refer to the questions later on. So there are some deep switches in the NIM card. Other than the address, you also need to make sure your NIM card deep switches are also set properly. So of the four deep switches, the first and second have no function, and the third and the fourth you have to keep them on under all circumstances. If your MUX for all current MUX, the, the NMS master slave function was available before, but right now it's not required. You can also access the MUX locally or remotely in slave mode. And MUX, when you are using the MUX, we are individually with along with STM or microwave. We normally use the internal NMS. So deep switch number 1 and 2, you can just keep them off, and 3 and 4, make sure they are on when you are using the multiplexer. So in NIM card, basically, you have to. There are two configurations, hardware configurations that need to be done while inserting a NIM card. One is the address, and second is the deep switch setting. Okay. So one of the major functions of the NIM card is to monitor the health of the incoming E1 signals. There are two sets of alarms for each for port A and port B, and each alarm has a different meaning, and depending on where the failure is, you will get a particular alarm. So the first alarm is receive fail. Receive fail alarm means that there is no electrical signal being received at the E1 port. So if there is no connection between STM and MUX, or the STM is switched off, you will get this receive fail alarm in the E1 port. Next one is AIS, or alarm indication signal. This means that you have a electrical signal in the E1 port, but there is no data or there is no content in that signal. That signal itself indicates that there is a failure somewhere beyond the immediate connection. That means if you are getting an AIS signal, you either have a higher order system like the STM or microwave radio equipment connected to your MUX, but the link has failed somewhere beyond that immediate higher order system. We will discuss these two alarms a little bit later. Next one is loss of synchronization. This alarm indicates that we are getting some signal which has some content or some payload, but the quality of the signal is highly degraded and it's not usable anymore. So all the first three alarms that I have discussed, they are major alarms. If the MUX receives any of these three alarms, it will treat that particular port as failed. So in the name card in the left side of the image, you can see in the name card there are 6 alarms at the top side and 6 alarms in the bottom side. So top side the 6 alarms are for port A and bottom side the 6 alarms are for port B. So we have discussed the two loss. The next alarm is remote multi-frame alarm. This alarm indicates that you are receiving a signal from the remote end, but
Devdut ji,
yes,
somebody asked in chat box, please elaborate again alarm.
okay. I'll clarify it. I'll show you with diagram which alarm comes when. Okay, so I think it will be clarified then. Okay, so I'll continue right now. I'll come back to these alarms once again. Okay. So remote multi-frame alarm means that you are receiving a signal. Remote multi-frame alarm means that you are receiving the signal from the remote end, but the signal being transmitted by the MUX which is receiving the remote alarm is not reaching the other end. Next is bit error rate or bit error ratio. This actually has two states, which is a minor state, which is 1 in every in 10 to the power 6 bits is there is an error, and there is a major state where 1 in every 1000 bits there is an error. So this is basically bit error rate. When bit error rate alarm comes, that means the signal that is being received is degraded quite a bit, but not as much as when the LOS alarm comes. And next, the final alarm related to the E1 ports or 2MB ports are remote alarm. The remote alarm indicates that there is no failure between the immediate link. The link between the MUX that is receiving the remote alarm and the next MUX is okay, but there is a failure somewhere ahead in the link. Okay, so we will come back to this again. We will first discuss about the alarms, this part, before we go ahead. So this is an example of a network. Always the first two muxes of the network has to be connected in with port between port A of those two muxes, and the next from the second hop onwards the links should be B to A. So this is a network where there is no failure currently. So all the systems are showing system OK indication, and right now. So right now, if an alarm occurs between say station P and Q, the first two stations, so they are both connected through port A. So station P will receive an AIS alarm in port A. Station Q will also receive an AIS alarm in port A, and all the other stations, because there is a failure towards port A, they will receive a remote alarm. Okay. And in the next case, there is once again a failure, but now between stations R and S. In this case, port B of station R has failed, so it's going to receive a AIS in port B, and port A of S has failed, so it will receive a AIS in port A. In case of station Q, there is a failure that towards port B, but not immediate. So it is receiving a remote alarm. In case of station P and station T, both these stations there is a failure towards their port A. So both of them will also receive a remote alarm. So next is RxF. So here the failure is not in the optical link. The failure is between the STM and the MUX itself. So in this case, no electrical signal is reaching from the STM to MUX. So the MUX will get a receive fail
सर
alarm.
मुझे एक डाउट है सर
हाँ
सर ये वेफिल मक्स लगे हुए हैं हमारे टेस्ट रूम में
हाँ
तो सर कुछ मक्स के अंदर जब बी साइड ट्रिब्यूट फेल होती है लिंक फेल होती है तो उसमें इंडिकेशन आता है अलार्म का
ओके
ओके सर एक रतलाम भोपाल मक्स है उसमें आता है उसके अलावा एक हमारे रतलाम नागदा रतलाम गोधरा इसमें लगे हुए तो उसमें इंडिकेशन नहीं आता सर जब केबल कट जाती
इंडिकेशन नहीं आती
है
रिपोर्ट फेल होने में.
हाँ
हेलो
बी पोर्ट फेल होने पर नॉर्मल दिखा रहा सर वैसे वो
हाँ तो वो MUX आपका ये एन टर्मिनल में है, एन टर्मिनल मोड में है, इसलिए आपका बिपोर्ट फेल में इंडिकेशन नहीं आएगा.
तो
वो
उसके लिए क्या
आपका
करते
आपका वॉइस एक्चुअली क्लियर नहीं आ रहा है अभी. अच्छा, if the MUX is in n terminal mode, say in case of here in case of stations P and stations T, these two are in n terminal. These two stations are kept in n terminal mode. Only when there is a failure in port A, if the MUXes are in protection, only if there is a failure in port A will the MUX start monitoring the protection path through port B. Otherwise, if there is no failure in port A, in case of N terminal, the MUX will not show any alarm in port B even if there is a failure. Okay. As I was discussing, this remote RxF or DC fail alarm, it will come when no electrical signal is reaching from the STM to the MUX. Okay. So accordingly, once again, since there is a failure, stations Q and stations P will receive remote alarm in their corresponding ports. Station S, because the E1 is not reaching station S, it will receive an AIS alarm. T will once again receive a remote alarm. So one thing you will notice that all these alarms that are related to the E1 ports, they always come in pairs. Wherever the link has failed, you will get an alarm in both. Is the remote multi comes paired. Hello. Okay. Okay. So remote multi-frame alarm comes when there is a failure of a single path. If the chance path has failed, but receive path is okay, then you will get the remote multi-frame alarm. Okay, so in this case, you can see that the trans path of station R, which is the receive of station S, that has failed. Since S is not getting any signal, S will receive an AIS as usual. But in case of station R, since it is getting a it is receiving the signal from station S that contains this alarm of remote multi-frame that is being generated by station S and received by station R. So when you are getting a remote multi-frame alarm, it basically indicates that there is a failure of a single path. Okay. So let's go back to once again. So is there any doubt or any question regarding the alarms? Please let me know. Shall I repeat it once again, or is it clarified? Okay, so let us move on. I'll if needed, I'll discuss the alarms once again at the end if there is time.
Sir, pictorial diagram I want to see again, sir.
Okay, okay. So I'll explain it once again. This is a example of a protected network. Okay. There is currently as per the diagram there is no failure in the network. So all systems system OK should is blinking should be blinking in the name card, and there are no tributary alarms in any of the muxes. Okay. So for example, there is a failure between stations P and Q. For example, there is a fiber cut. In that case, you will get an AIS alarm on both sides of the failure. So station P and Q, since both they were connected through port A, you will get a AIS alarm in both their port A. In station R, S, and T, since there is a failure towards their port A, you will receive a remote. They will receive a remote alarm in their port A. Okay. So I'll discuss once again this diagrams when we are discussing the tables. Okay. So in this case, there is a fiber cut between stations R and S. So once again, R, since failure is towards its B port, it's receiving a AIS alarm in port B, and S is receiving AIS alarm in port A. Station Q, since the failure is towards its port B, it's receiving a AIS alarm in port B. Station P and T, they are also they should also be receiving remote alarm in their both their port A's. Okay, so this is basically the discussion about the AIS alarm. Normally, when there is a fiber cut, you will always see this AIS alarm come up. Or if they say there is a STM has shut down in one of the stations, in the adjacent stations, you will also receive this AIS alarm. Next is the RXF alarm. As I discussed, RXF alarm is when the MUX is not receiving any electrical signal from the higher order system. In this case, the switchboard or CAT cable that is connected between the DDF of the STM to the MUX that has failed, that has been disconnected. In that case, the MUX will not receive any electrical signal from the STM, and in that case, it will get an RxF alarm in station R. Okay. In case of station A, the STM is not receiving any data from the remote end, so it will generate an AIS alarm and will provide that alarm to the MUX. So in case of station S, it will get an AIS alarm in port A, and due to this failure, the other stations will also receive remote alarm in their corresponding ports. Okay. So this is a case of remote multi-frame alarm. The remote multi-frame alarm comes when there is a failure of a single path, that is the trans path of a particular MUX. So in case of remote multi-frame alarm, the MUX at the other end should also be receiving an AIS or an RxA for a loss alarm. So the MUX that is receiving the remote multi-frame alarm, it can receive the data from the remote end, the MUX at the remote end, but the data that it is transmitting, that is not reaching the remote end. That is why this remote multi-frame alarm will come. Okay. We'll discuss this diagrams once again when we are discussing the tables. Okay. So there are also a few other alarms and indications in the NIM card. The next one is a configuration alarm. So when you are programming the card parameter in the architecture, the whatever you have configured through the NMS, if it does not match what is physically present in the cards that are physically present, in case of any mismatch, this configuration alarm will come. So the configuration alarm, although it is in red color, it is not a major issue, because only the channels where this mismatch has occurred, they will not work. The channels where the physical whatever is physically present in the MUX and whatever you have configured, if they match, those channels will work. So configuration alarm, if there is, say you have configured a card in a slot, but physically the card is not present, or vice versa, this configuration alarm will come. It also comes sometimes due to the failure of channel cards. Also, this configuration alarm might come. Okay. Next is the two indications. These are not alarms. These NMS and bypass. NMS indication will blink when someone is accessing the MUX through NMS, either remotely or locally. And the bypass is also an indication. It indicates that if someone has given a bypass command to the MUX, while executing that command, this bypass indication will blink. Okay. So let's discuss what are the programmable features of the MUX. So first, the things that you have to configure for the MUX in the through the NMS, these configurations are all saved in the NIM card. The two main things that you have to configure are the card parameter and cross connect. So card parameter is whatever you are physically inserting in the MUX, the same thing you have to configure using the NMS for them to work. And the cross connect table is, of course, which channel needs to be dropped where, whether some channels needs to be conferenced or not. That part you have to configure in the MUX. Next, configuration of channel assignment for various alarm conditions. These things are not really required. As I discussed, the 2 MBs are being monitored by the MUX, for which the alarms that I discussed are shown, and as well as you can give some external alarm inputs to the MUX itself, which can also be shown. External means some environmental alarm inputs, things like whether you have AC power available or not, whether or some other things like whether door is closed or open, that type of external alarms indications you can also configure, provide input to the MUX, which is visible through the NMS. In addition, you also voltage and temperature is also monitored by the NIM card, which are also shown in the NMS. There are also some other facilities that are provided, some diagnostic facilities that are provided, which are also implemented by the NIM card. Like you can loop back through NMS command. You can loop back either a particular voice channel, a 64 kbps channel, or an entire E1 channel. You can provide a tone for testing voice channels, things like that. Okay. So one of the major things that need to be done in the configured in the MUX are the cross connect tables. But there is not just this a single cross connect table that will be sufficient for handling all situations. To handle the failure, we need to configure at least 5 cross connect tables. The first one, the main table that needs to be configured is of course the normal table. That is whatever cross connect needs to be done, and when there are no failures, when the MUX is working in the normal condition, all links are okay, and which accordingly the MUX needs to, according to which table the MUX needs to work. That is the normal table. The next 2 cross connect tables are for having any major alarm in port A or port B. These are called faulty A and faulty B tables. So if you have any of the major alarms like AIS, RXF or loss, or a major case of BER, the MUX will automatically switch to the corresponding faulty table. Okay. And similarly, you have two remote tables which will the MUX will switch to in case of remote alarm in either port A or port B. So basically, you need to configure these all five tables for the MUX to handle all any type of failures. Okay, and the final table is digital bypass table. This table is the MUX will not switch to its table on its own. If you give it a command through NMS to switch to this bypass table, only then the MUX will switch. Okay, so you have to download all 5 tables, that is normal, faulty A, faulty B, remote A and remote B, to handle any failure conditions. So when will these tables when does this table come into play? Let's see. So we once again come back to this diagram. So when there are no failures in the network, all equipment will be working in the normal table. Okay, there are no alarms anywhere, so all MUXes are working in the normal table. So next, say there is a failure once again in between station P and Q. So station P and Q, they will both receive AIS table, AIS alarm in their port A. So station P and station Q, they will automatically switch over to faulty A table. Okay, the NIM card, as soon as it receives this AIS alarm, it will automatically switch over to working in the faulty A table. In this case, stations R and S, we have disabled the remote table switching in case of RSS, because in case of intermediate stations, remote table and normal table and remote table, they are usually the same. There are very few exceptions which we will discuss later on. So under normal circumstances, it's advisable to switch off the remote table switching. How that is done, we will discuss later. So stations R and S, since they are intermediate stations and we have kept the remote table switching disabled, they will keep working in the normal table. But to handle the failure T, which is the station at the other end, there we need to switch to the remote table to handle the failure. So station T will be working in the remote A table, since it's getting a remote alarm for port A. So this remote table, to enable or disable the remote table switching, it's done through the tributary card. We will discuss how it's done. Okay, but basically to handle failure, what we need is both end stations remote table switching needs to be enabled, or like in station P and station T, all other stations, intermediate stations Q, R, and S, remote table switching needs to be disabled. That is the best, most suitable working configuration. Next, once again, there is a failure at between stations R and S. In this also, since there is a in station R, there is a AIS in port B, the MUX will switch to faulty B table. In station S, the MUX will switch to faulty A table, since there is a failure AIS alarm in port A, and all the other stations will receive a remote alarm. So both end stations, since we have kept the remote alarm switching enabled, they will switch to remote A table, and station P, since remote alarm switching has been disabled, it will keep working in the normal condition. In this case also, it's a similar situation. The failure is between stations R and S. So once again, R and S, they will switch to their corresponding faulty tables whichever side the failure is. Others, according to the alarm, they will switch their tables as well. And finally, in case of RMA alarm, see, this is a very specific case. In here, the MUX that is receiving the remote multi-frame alarm, since its received data is okay, it will not switch. But in case of station S, since it's receiving an AIS, it will switch to the faulty A table. Okay. So basically, what you need to remember is that the MUX, the table on which the MUX is working at the moment, it depends on what alarms are in the NIM card of that MUX. Okay, so in case of AIS, RXF, or LOS, the MUX will automatically switch to the corresponding faulty table. And in case of remote A or remote B, if remote table switching is enabled, the MUX will automatically switch to the corresponding remote table. Okay. So basically, that was the details of the NIM card, the functions and the features and whatever configuration needs to be done. So the next most important card is, of course, the tributary card. So the tributary card does the actual heavy lifting of the MUX. Okay, so the actual multiplexing, demultiplexing, conferencing of control channels, and actual implementation of the cross connect, it's all being done by the tributary card itself. The NIM card monitors the health, it stores the the decisions. The tributary card does the actual work of multiplexing and implementation of the cross connect. Okay. So first, let's discuss about the alarms that are in the tributary card. So there are two main alarms. These the first two alarms that you see, they are consequence of whatever alarm has come in the NIM card. So if you have a AIS or RXF for loss or major case of BR in either port A or port B in the NIM card, you will get a TAF or TBF alarm in the tributary card as well. So your actual failure is indicated by the name card. Tributary card, these alarms, TF and TBF, they only indicate that the port has failed. But what type of failure, that you will have to refer to the NIM card to make sure you understand that. The next these four are basically, they are not alarms, they are indications. The first one is external clock, sorry, internal clock. So if the MUX is working on its own internal clock, this internal clock indication will bring. Next is digital bypass, loopback A and loopback B. They are self-explanatory. Digital bypass, all these are commands that you can give through NMS. While the MUX is executing these commands, these indications will blink or stay steady. Okay, so you can give a digital bypass command. Basically, digital bypass command is when you want the MUX to switch to the bypass table, cross connect table. You can give a digital bypass command. While the MUX is executing this command, this digital bypass indication will glow. Same for loopback A and loopback B. You can give a NMS command to loop back the E1 ports. So whenever the MUX is executing this NMS commands, in that case, these indications will glow. Okay. So once again, the MUX, the tributary card, there are some hardware configurations that need to be done in the tributary card. There are 8 dip switches, and there are multiple jumpers, but only one that needs to be changed. You don't need to change any other jumper for normal operation of the tributary card. So the dip switches each has the following functions. The first one is to activate or deactivate CRC mode. So this will always be kept in off condition. Then I'll come back to 2 and 3 later. First, let me discuss about switch number 4. Switch number 4 is whether you want to transmit remote alarm or not. If you keep it off, the remote alarm will be transmitted. If you keep it on, remote alarm transmission will be disabled. So this dip switch number 4 always needs to be kept in off condition. So dip switch number 5 is either you can you want the MUX to be working in drop inside mode. That means both port A and port B will be active, or in N terminal mode. In which case port B will be deactivated. Only port A will be activated. So dip switch number 2, it is dependent on this dip switch number 5. So if you keep the dip switch number 5 in off condition, dip switch 2 has no function. So if you switch on dip switch number 5, which is turn it into an N terminal mode, after that you can switch on dip switch number 2, which is to whether you want the MUX to work with in ring protection mode or without protection mode. So to switch on the protection mode, you have to switch on dip switch number 5 as well, 2 as well. Okay, now dip switch number 6 is once again extracted or internal clock. The first MUX of any network has to work in internal clock mode. All the other MUX will keep working in extracted clock mode. So only the first MUX of the network should have this dip switch number 6 switched on. All the other MUXes, they should have dip switch number 6 switched off. Once again, dip switch number 3 is dependent on this dip switch number 6. So dip switch number 3, it indicates whether to extract clock from port A or port B. So if dip switch number 6 is switched on, it's already working in internal clock. So in that case, dip switch 3 has no function. If dip switch number 3 is switched off, 6 is switched off, then dip switch number 3 decides which side the clock will be extracted from. So normally we always need the clock to be extracted from the port A. So dip switch number 3 will also be kept off in all MUX. Dip switch 7 is for balanced or unbalanced port. For STM equipment and for most modern equipments like modem or radio microwave equipment, mostly 120 ohm balanced E1 port is being used. So dip switch number 7 will be kept on in all conditions. Now the final dip switch number 8, it is to, as I discussed before, it decides whether remote table switching will be enabled or disabled. Okay, so in the end stations, this remote table switching needs to be enabled. So in both end stations, this dip switch number 8 needs to be kept on. In all other stations, dip switch number 8 in all intermediate stations, they need to be kept off. Okay. And finally, there is one more jumper that needs to be set in this tributary card, that is jumper E33. In case of drop insert, that means intermediate stations and in N terminal without protection, this jumper has to be set in pin number 1 and 2. In case of N terminal with protection, in both ends, the jumper has to be set in pin number 2 and 3. Okay. So let us see the example of what this dip switch setting should be in various cases. So this is a network once again, a normal network with. So let me first discuss this. This is a normal network without any protection. In this, you can see that dip switch number in the first station, dip switch number 5, 6, 7, 8 has only been kept on. So 5 is for N terminal in the first station, station P. 5 is for N terminal, 6 is for internal clock, 7 is for the impedance, input impedance, and 8 is for remote table switching. Okay, and E33 has been kept in pin 1 and 2. This is for an unprotected network. On the other end, also in station T, last station, except up dip switch number 6, which is for clock, all the other dip switches are same as the first station as well. And in case of the intermediate stations, the all dip switches except 7 is kept on, and E33 jumpers in all cases are to be kept in pin number 1 and 2. Okay, so this is for an this is the dip switch setting for an unprotected network. Okay. So if you have a protection, there is a slight change in the configuration. Yes, any questions?
No.
Okay. Okay, so in case of protecting a network, there is a slight change in the configuration. The configuration of the intermediate stations, they stay the same. Okay, only dip switch number 7 is on, and E33 is in pin 1 and 2. So there is no change in any of the intermediate stations. Only change has to be done in the 2 end stations. So what changes? Only 2 changes needs to be done. That is, of course, dip switch number 2 has to be switched on in both ends, and E33 jumper has to be set in pin number 2 and 3. Okay. To implement the ring protection, only the station, the 2 terminal stations, the configuration has to be changed. All other stations, no need to change anything. Okay. So up to this, are there any clarifications or questions? Any clarifications needed?
Hello, sir.
Yes.
Sir, if the NIM card or tributary card may be faulty, then
Yes.
what type of alarms are there?
What type of alarms?
Yeah. So if
Basically,
you have said discuss about the network's alarm, port A, port B, or any
yes.
faulty in the network. But if the cards are faulty,
Acha.
what are the alarm?
Basically, the NIM card monitors the 2 MB ports. So, if the card misbehaves, there are no specific alarms. Any specific alarms you will not get. The functioning of the MUX will be affected in case of failure of NIM card or tributary card. But in case of failure of either of these cards, you might not get any alarm. There, the alarms might there might be erroneous alarms, like maybe you can get loop back or bypass indication blinking without giving the any command from the NMS. But in general, there is no indication on alarm in case any of the NIM or tributary card fails.
One question, sir.
Yes.
Sir, question is unprotected network. If shows in your picture, if T station
Yes.
is T stations MUX connected B port,
Yes.
any network.
T station MUX.
T station MUX connected, matlab B port is connected in any network, but P station is not connected B port. So which is sys setting?
No, actually, you see, you have to when you are providing a protection, you have to provide end-to-end protection, right? So
Yes, sir.
if you are connecting B port of station T, you have to connect the other end to the B port of station P only. You cannot connect it somewhere else.
Yes, sir.
Okay, so if you are connecting B port of station T to a MUX in a different network,
Yes, sir.
in that case, the ring protection will not work.
G.
Okay, so for implementing ring protection, you have to
Yes, sir.
connect the end B ports of the two end stations only. Okay,
Yes.
if you want to connect it to a different network, then you have to make the say station P. You want to extend the network, then you have to make the station T into drop inside and then connect. You cannot keep it in N terminal mode and then connect it to another MUX in another network. That will not
Yes,
work
sir.
properly. Understand?
Yes.
You have to implement this type of network for it to work properly. Okay, so I'll move ahead. Any questions regarding the NIM and tributary card? Because these are actually the two most important modules in the multiplexer. So the functioning of these two needs to be understood properly for maintaining.
Hello, sir.
Yes.
Sir, at one of my stations, MUX is getting hanged frequently, and the tributary card, all alarms are showing up. I couldn't find the problem actually. Right.
In the tributary card, all alarms are showing up. Basically,
Yes,
I think that it is happening after while the MUX is working, then hanging, or if you are powering on immediately, all the alarms are showing up. I mean, it is
No, it's while working.
while working, the MUX is hanging immediately.
Yes.
Acha. In that case, you have to replace the tributary card. Because I think that card is for you. If you replace the tributary card, it will that will be the best option. Okay.
Actually, sir, from that MUX we have given to port Vishakhapatnam port, that is, and it is in cable, quad cable. The quad
Okay.
cable condition is not good. Although we have provided the isolation transformer between this,
Acha.
could this be the problem that MUX is hanging?
Ah,
Because also
this.
the channel where it is programmed, that is in fourth channel, it is showing the E alarm. E and M is there, na sir? E light is also glowing every
No,
time.
the E light is going. That is not a local issue. That is some the from where you are giving somewhere M lead has been earth in the other end of the net, channel. M lead has got earth. That's why E is showing. E is not not a local issue. Okay. E lead loads because it's receiving the signal from somewhere from a remote end. And by remote end, I do not mean that where you have forwarded the channel, not that side, where the cross connect has been made. The other station, from that end, M lead has been earned. That's why he is getting. E is not an issue, not a local issue.
No, sir. At other station there is no MUX. We have given in quad cable only.
No. They have
Control
given
in quad cable only to the port.
No. That side I'm not saying. But you have given that that you have dropped that channel from somewhere, na? You have dropped that channel from some other station, right? Cross connect has been made. I mean the MUX side. The wherever you have say you have in for example in station T, say you have given it through quad cable somewhere, but the channel is connected from station T to station S, na? So if M lead is earth in station S, you will get E lead in station T. So it's not an issue of the quad cable side; it's the issue of the other side, the optical fiber side, E lead. Understood?
So in this case, we have to change the tributary card, right?
In this case, you have to change the tributary card and make sure your earthing is okay. All right. This if hanging problem we have observed mostly it occurs due to an earthing issue. And one mistake I have seen many people do, they give DC earthing to the charger. Both AC and AC is already earthing is already given to the charger through the AC socket. DC earthing is also connected to the charger. That should not be done. Okay, so in that case, AC and DCR they become common, and any spike that is coming from the AC side, that will enter into your DC network, DC systems. So if you
we have to provide.
if you have provided if you have provided DC earthing to the body of your charger, you have to remove that. AC and DC earthing should not be made common at any point. This is one other issue that we have observed. Okay. And earthing, you please make sure your earthing is okay or up to the mark. And in case that the most you can do is you can provide isolation transformers if you are taking it say a long distance. And there are also
we provided already.
and there are also some other RDSO spec surge protection devices for voice channels, for both voice and UN channels. Okay, you can use them also. There, I think that will also give you some protection. RDSO spec আছে?
Sir, his question may be, मतलब how far distance may be extended after we are deriving the circuit, because he is extending to the next station control.
Look, in case of non-RE up to 7 kilometers also we have, it has worked. So in case of RE, it's not advisable that much, but still 4 kilometers will still work. But the problem remains the same. It will, in case of RE area, it will accumulate a charge. The cable will accumulate charge, which will
Yes,
get
sir.
discharged through the MUX's channel itself. That is why
That is
Sir, actually, forgot to tell you one thing. That at the point where we have given to the port, actually there are 3 parallel connections given from the same MUX point for control channel, and all are in cable.
no, that you should not do. In that case, you should use a bridge circuit, a hybrid circuit. That would be better, because hybrid circuit will allow to match the impedance, because you see the loop resistance of you cannot, you should not be attaching 3 parallel lines in a forward circuit. You should use a hybrid circuit or a bridge circuit to match the impedance. Each card is like it does the same job as conference. Okay, it can take one forward channel, and it can distribute into 5 more forward channels or 3 more forward channels. So it's basically like a 6-way amplifier. Okay, so you can input a forward in any one of the ports, and it will distribute it to 5 other ports. That in that case, the impedance dropping will not occur. In any case, even if you are giving 2, that also should not be given from the same port. In case you are using you are going to give multiple control channels or multiple forward channels, you should always use a bridge circuit. It's still available in the market, and it protects your MUX quite a bit. And I mean, even wherever we use this, we do not. We use a bridge circuit wherever we connect multiple channels to the same port. And also, it would be better if you use a surgeon lighting protection arrangement, not IPM. There is a RDSO spec for surgeon lighting protection arrangement for both voice circuits and E1 circuits. You can explore into those. They help in protecting the MUX quite a bit. Okay. Okay. Any other questions?
Okay.
Okay. Okay. So let's move into the interface modules. Okay. So let us start discussing the interface modules. Basically, there are multiple types of interface modules that are available for the multiplexer. The first few are the most used are, of course, the voice modules. There are certain subsections under the voice module, that is 2-wire, 4-wire, which are used in your control circuits or data logger, or whenever you have to give analog circuits. Next is, of course, subscriber and exchange. These are used to extend exchange telephones, auto telephones, dialing type telephones. So subscriber end is where the telephone is being installed, and exchange is where you are providing the dial tone from the exchange. The subscriber and exchange, they always work in pair. So one end you will have a subscriber, one end of the channel you will have subscriber interface, the other end you will have exchange, and the final type of voice module is the hotline module. So it is basically the same module as subscriber, but needs to be changed. In case of hotline, you have two hotline modules at two stations configured as so, and you cross connect them, and if you pick up the telephone at one end, you will ring, phone will ring at the other end. Okay. So basically, there are three types of hardware that are voice hardware that are available. The 2-wire, 4-wire, subscriber, hotline, and exchange. Okay, so the same module you can use as either subscriber or hotline. And next, there are few data modules that are interface modules that are also available. The most commonly used is the G703 high-speed data. These were used for UTS and FOIS at many places still. Next is V35, and then you have the low-speed data module, which further has lower speed than 64 kbps. That is like 9.2 kbps and 19.6 or something like that. Then you have N into 64 kbps high-speed data. It can this module can take multiple 64 kbps and provide you bandwidth higher than 64 kbps. And then finally there is the ISDL module. Okay, so we will concentrate on the voice modules only because they are the ones mostly used. And as far as the G703 module, that is also used in many places, but there is no much configuration or anything required in the G703 module. So we will mostly concentrate on the voice module. Okay. So this is the ENM module. So there are certain 4 jumpers that you can see circled here. So in one side of the jumpers, you can see 4 were written, the other side 2 were written. The picture on the left is set in 2-wire mode. The one in the right is set in 4-wire mode. Okay. So the same module you can configure either as 2-wire or 4-wire. The jumper numbers and setting is given below. So basically, the jumpers that needs to be set has been circled for your reference. Okay. Similarly, you have a hotline subscriber adapter. So this is our new hotline subscriber adapter. Is the similar setting. The jumpers, the left side is set as subscriber, right side has been set as hotline. Okay, so and below you have the configuration that needs to be done for subscriber and hotline. Okay. So any in case of our voice card, I think most of you are aware that each voice card has consists of 4 channels. So you can configure any channel as any of the any channel as either hotline or subscriber. Just make sure that whatever you are configuring, making physical configuration, you do the same in the software, and you do not get any channel error. Then the channel will work. Okay. Okay. One question I got was that we have tried multiple times, but the latest NMS version is not compatible with the version of the Windows 10. Please advise how we can use fully functional NMS in Windows 10 OS. Okay, it's not that is not accurate. There are some I think you may face some issues while installing the our latest NMS software in Windows 10, but it gets installed and it does work. We have been using Windows 10, our NMS through Windows 10 without any issue. Just make sure that the USB to serial converter that you are using, if you have to use a USB to serial converter, make sure that the USB to serial converter that you are using is a good quality one, because main issue that we face is the driver of the USB to serial converter are not of many USB to serial converters are not compatible with Windows 10 64-bit. But our NMS does work on Windows 8 and Windows 10, both 64-bit and 32-bit. There are no issues with the our NMS currently. Okay, second is we need a way how we can move NMS into new system with all existing configuration. Okay, currently there are no specific or recommended way of copying the entire network to a new system. Okay, there is no officially recommended way of doing that. So I cannot discuss that. It is my handling problem facing state. Acha. It has been seen that there are MUX and card handling problem facing several times in respect to other MUXes. Look, mostly regarding the hanging, one of the things is the main issues that need to be checked is the earthing of the multiplexer, and make sure that your AC and DC earth are kept separate. Make sure you do not connect DC earth to the charger. Okay, because AC earth is already connected to the body of the charger. Make sure you do not connect the DC earth to the body of the charger, because that is something we have observed in many places. And please use surge and lighting protection arrangements wherever possible. Otherwise, I think most places our MUX is working fine. Once these issues are, mainly the earthing issue is taken care of, our MUX is working fine in most places. Earthing of equipment is there is no detail to be discussed. Just DC earth, at least it has to be less than 5 ohms. It's best if it is less than 1 ohm, but even if it is less than 5 ohms, earthing is okay. DC earth has to be connected to the best way to do is to attach it at the back plane. Next is protection level, how to work like BSNL Railtel. Protection, we have already discussed this ring protection. We have already discussed, this is the switch setting that needs to be done, and we will also discuss the cross connect that needs to be done for protection. Chat box. Okay.
Hello.
Yes. I'm just checking the chat. Please go ahead.
Sir, can you hear me?
Yes, I can hear you. Please go ahead.
Hello.
Yes. Hello.
Sir, can you hear me?
Yeah, I can hear you now.
Sir, if there is a BS patching in midsection,
Okay.
so how can we implement that?
In midsection,
Yes.
when you say, acha, if you are, I mean, do you have multiple patchings? See this ring protection. I'll discuss. I'll have to discuss a different equipment for that. The ring protection, it only works end to end. Okay. So there is a separate module, that is the loop protection module. So if you want to provide, um, uh, there are also an advantage of the loop protection module. That is, it not only protects the control channels, but it also protects the entire 2 MB. If you want to give protection in the midsection, you will have to use a separate loop protection module. That would be more suitable than using the ring protection. This ring protection is strictly for end-to-end protection. If you have to provide ring protection in the middle, you have to install 2 muxes there. You have to put a separate protection mux and start a new link from there. So that is not advisable for implementing protection in midsection. The best way to do is to use a separate loop protection module.
So some other card available called protection model.
And yes. It's not a card. It's a separate module, 1U module. It can be used with our mux or any other mux as well. Okay, it's a separate module. It's I think Pancom has a similar thing. The loop protection card. It does the same thing, but instead of a card within our mux, it's a separate module so that it can be used not only with our own mux but also with any other multiplexer, or you can protect any other E1 with that loop protection module. The functioning is the same, but it's a separate module. Okay.
Fit into this rack.
So, sir,
Yes.
is there any provision in MUX to adding branching card?
There is a provision of adding E1 branching card. Yes. But that is if you have a if your traffic is high, it's advised not to use the branching card, but use a separate mux and do the patchings in voice level. If you have only or 2 or 3 channels, you can use the branching card. But what I have seen is that the configuring branching card has been very confusing for most at most sections. So configuring it due to this confusion, we advise to avoid the branching card and install a separate multiplexer.
Okay.
Okay. Confusion. Okay, so I have received a few questions in the chat. Deep Switch 3, I think, okay, this, I don't know whether this is name or tributary card Deep Switch. I'll just. Achha, in case of Deep Switch setting of name card, you just just don't confuse it. You just have to keep 1, 2 off and 3, 4 on. Okay, in all stations. So there might not be any confusion regarding the Deep Switch setting of name card. In tributary card only, Deep Switch setting needs to be configured as shown in this diagram. In case of name card, you do not need to. There is no, it depends on no location or anything. In all stations, if you have a current make MUX, and by current I mean made after 2009, and all DIM cards 1, 2 will be off and 3, 4 will be on. Okay. There is no question of master slave. Okay, please elaborate alarms once again. I think I have already done that. If anyone wants to discuss the alarm, let's know. Frequent again. This was station MUX.
Sir, where will we connect the loop protection?
The loop protection module. What? The loop protection module is connected the E1 between the E1 connection of the STM and MUX. Okay, so you have a separate. You have one working E1, which the MUX is already working on. You have to provide a separate E1 in the entire network. So the loop protection module will be connected between the STM and the MUX. Okay, so we will. I'll give you a show you the loop protection modules diagram once. Okay. Okay, so let's now discuss about the cross connect tables. Okay. So basically, there are 3 types of cross connects that needs to be done in case of our MUX. There is the linear, which is just point to point from one channel to another channel. It can be either port A, port B, or port C. Port A and port B are the two 2MB ports, the multiplex ports or aggregate ports. They can be they are called, and port C is the voice channel. So all the voice cards and data cards from slot number 5 to 9, all those are interface slots. Whatever cards go in there, there are all interface cards, and they all are there to serve port C. Okay, port A and port B are the E1 ports at the back of the MUX, and all the cards, voice cards and data cards, they are all there for port C only. So there are 3 types of cross connects, as you can see, point to point. Either you can connect a time slot of port A to port C, port B to port C, or port A to port B. Okay, so only 2 channels connected among themselves. And there are 2 other types of cross connects. That is the conference cross connect, in which 3 channels can be connected. So any signal that coming from any one of the channel gets distributed to the other 2 channels. That is the conference type. And the semi-conference type also, here 3 channels are connected, but there is a difference between the status of the channels in case of semi-conference. So there is one master channel and 2 slave channels in case of semi-conference. So in the diagram, A is the master channel and B and C are the 2 slave channels. So A can communicate fully with both time slots in B and C, but B and C can only communicate with A. Okay, and B and C cannot communicate among themselves. Okay. So basically, you have 3 cross connects in our in our cross connect table: linear, conference, and semi conference. All in case of control channels, and also some data channels like remote control or SCADA, we use conference type of cross connect. For all other applications, say auto telephone or UTS or data logger or FOIS, whatever, we use linear type of configuration. Semi-conference is mostly you almost never used. Only few places for SCADA semi-conference needs to be used. So there is a question: what type of conference for RC SCADA? Yes. So for analogs for voice channel RC SCADA type of cross connect, in most places this conference type of cross connect is done, but at some local some sections we have seen that there are some issues we are facing with conference type of cross connect. In those spaces we use semi-conference type. But the issue is that semi-conference type is if you are using semi-conference type cross connect, you have to keep remote table switching enabled in all stations, and you also have to configure remote tables accordingly. So if you are using, if you have to use semi-conference cross connect, in that case you have to make sure that your remote table switching is enabled at all stations. And also for semi-conference cross connect, the normal table and remote table are often different. So that exception needs to be handled in case of semi-conference type cross connect. But in most cases, conference type of cross connect is can sufficiently function for remote or SCADA circuits. Okay. So this is basically a standard time slot one that we have shown here. That is the standard conference type cross connect that is mostly used for all control communications. Time slot 2 and 3 that we have shown here. Time slot 2 and 3 that we have shown here are linear circuits, but in channels like data logger, accel counter, UTS, this they have to be configured as channel 2 and 3. So adjacent stations are given in one time slot. In a particular station, one side is given in normally given in one time slot. The other side is given in a different time slot. This is because that if you switch off our multiplexer, the U1 ports, port A and port B, they get bypassed. So if you are giving it in the same time slot, say the cross connect between station 1 and 2 and station 2 and 3 are made in the same time slot. If you switch off station 2, then the channel gets bypassed and station 1 gets connected to station 3. So to avoid that, it's best to use different time slots for alternating for both either sides of a station. Okay. And here channel 4 that is shown, time slot 4 that is shown, that is a direct connection from station 1 to station 4. Yeah, cross, for circuits like auto telephone and mostly auto telephone, this type of cross connect is needed. In case of this time slot 4, you can see that in stations number 2 and 3, the channel has been bypassed. Okay. So what we have shown here, that is the normal configuration, right? So to handle a failure, we need to configure the faulty A and faulty A, faulty B, and remote A, remote B tables, right? So in case there is a failure, so this yeah, down again. So in case of a failure, the only towards port A, in only the channels that has been provided from port B, they will work. So as you can see, in case of in the normal table, that ABC cross connect has been made in the first in station 2. So in case of failure in side A, we have to eliminate the A port, which is the failed port. So in case of faulty A table, only B and C has to be kept. So in case of normal table, it needs to be a conference cross connect in time slot 1, A1, B1, and C1. But in case of the faulty A table, the cross connect should be only B1 and C1. B1, C1, B1, C1 only for the control channel. And the third time slot, that was already, there was no connection to port A. It will also needs to be configured in the faulty A table. But time slot 2 and time slot 4, since there was a cross connect from port A, they will not work. So there is no point in making those two cross connects. Similarly, in station 3 also, if there is a failure towards port A, once again, B2C cross connect needs to be done. B2C cross connect needs to be done. Port A has to be eliminated from the conference type cross connect. Channel number 3, you had in channel number 3, time slot 3, you have A to C, and time slot 4, you have A to B. So those two, there is no point in making those two cross connects. Only channel number 2, you already had B to C, that you are required to make. And in case of the last station, if port A, there is already a failure in port A, there is no making in any cross connect in port B any further. Okay. So similarly, in case of faulty B also, in case of control type cross connects, the B port needs to be eliminated in faulty B. Only all cross connects from port A to port C should be kept. All cross connects, all conference cross connects, whichever faulty table you are making, if you are making the faulty A table, so you isolate all the cross connects from port A. Port A should be completely blank in faulty A table. Similarly, in case of faulty B table, port B should be completely blank. And any conference cross connects that you had, you delete the faulty port. So if it was A1, B1, C1, in faulty A, it will be only B1 and C1. Since a port A has failed, there is no point in making any cross connect in from port A. Similarly, in case of faulty B, you isolate port B and make only cross connects between port A and port C in case of faulty B. In case of remote A and remote B, in most cases, except the implementation of protection, remote A and remote B tables should be, you should keep a copy of the normal table itself, except in the end stations. So as I discussed before, so if there is a say failure between station 2 and 3, you will have a if you have a failure between station 2 and 3, station 2 will switch to faulty B, station 3 will switch to faulty A. and the two end stations will switch to remote A table. So this is how I'll just take a break for about 5 minutes. Okay, I need to relieve myself a little bit. So we will resume once again in about 1:10. Yeah, sir. That's what I go through. Okay, shall we resume? শুনতে পাচ্ছি না দাদা? Shall we resume? Okay, I'll share
Okay,
the
okay.
number. Okay, I'll share the number in the comments, contact number for if you need technical support. Then contact any one of us.
All are requested to please keep your mic in mute condition.
তোমার 9433663256 তো 9433663256 তো একটাই ফাইল দেওয়া। So I have shared the number of few of our engineers in the comment. So please note them down. You can call me or either of them for any technical support. All right. So we were discussing the cross connect tables. So as we were discussing, in case of faulty A and faulty B, what you need to do is you need to remove all cross connects from the faulty E1 port, and in case of the conference cross connects, if it's a faulty A, you need to make only a B2C cross connect, and in case of faulty B, you need to make only an A2C cross connect. Okay. So in case of remote table, all the failures are handled by the, in case of ring protection, the failures are handled by the remote tables and the faulty tables at the end stations. So in case you have a end-to-end ring patching, as shown in this diagram, so you have to make your cross connect as shown in this table. So in case of in case you have a failure like shown in between stations 2 and 3, so station 2 will switch to faulty B table, station 3 will switch to remote B table, and the two end stations 1 and 4, there you need to make a conference cross connect in remote A table, so that when it switches to the remote A table, when it switches to the remote A table, we will the stations that are beyond the point of failure that can be accessed and the control channels can be connected to that side. Okay. So there are few commands that you can give for diagnostic purposes through the NMS. They are basically there are two types of bypass. One is the standard bypass, where the port A and port B can be bypassed for a limited amount of time. There is also you can also loop back the entire port A or port B. There are two types of loop back: the remote loop back and local loop back. Remote loop back, of course, the remote end will receive the loop back, and local loop back is you will receive the loop back where you are giving it. You can also loop back a particular channel. There, in case of A or B, it is always remote loop back. In case of C, you can have a local loop option of local loop back or remote loop back. In addition, you can also introduce a milliwatt signal, which you can, in case of voice channel, you can hear as a tone. All these commands can be provided through the NMS. Okay. These are the regarding the clock. I don't think this could be necessary. As I said, the first sessions always needs to be. The clock needs to be provided for from the first sessions. So that would be the end of our discussion for the day. Let me know any questions that you have. This is the start of the question answer session. So we have around 20 to 25 minutes. I can take any questions that you have. Achha, one thing I'll show you how to install the NMS, because that is, I think, a problem that many of you face. I'll show you how to install the NMS. This is a fresh PC. NMS has not been installed in this so far. स्क्रीन दिखायचं इंस्टॉलेशन स्क्रीन दिखायचं
Hello, sir.
हाँ yes, can you see the screen?
No, अभी कुछ शो नहीं हो रहा है इस पे.
अभी कुछ शो नहीं हो रहा है. I think the installation screen cannot be shared in this. No, they are not allowing me to share the installation screen. Okay, I'll share a few documents with you. If anyone has an issue with the installation of NMS, you please let me know. We can take it in um, online, like through TeamViewer or AnyDesk, we can help you install the NMS software. Okay, in Windows 10 also we can install the NMS software. There are no issues with that. You can let us know if you ever need. You can contact any of the numbers that I have shared, and we will assist you in installing the NMS software. Okay. So any other questions you have? I think it would have been best if we could.
तो सर ये कुछ क्वेश्चन इन्होंने जो है रिस्पांस में भी पूछे हैं।
हाँ,
इसमें एक पहला तो ये बोल रहे हैं कि बेफिल मक्स गेटिंग हैंग ज्यादा होता है, इसके लिए कुछ जो है बताएं कि
हैंग का इशू के लिए आपका मेन जो है अर्थिंग आपको देखना पड़ेगा। फॉर हैंगिंग इश्यूज यू हैव टू चेक द अर्थिंग एंड if wherever possible you use a surge and lighting arrestor device, that would be helpful. And one thing also you can do in case a system is not booting or you are not or system is hanging repeatedly. There are many ICs that sit on sockets in the NIM card and tributary card. Just before powering on, you press on all those ICs so that if there is any loose contact between the ICs, you can they sit in the sockets properly, and we can normally after that this MUX boots in many cases. Okay.
और कुछ लोगों ने पूछा है कि उनके सेक्शन में जो भी मक्स लगे हुए हैं उनमें बेबी कार्ड्स के फेलियर ज्यादा आते हैं, जो ऑटो के लिए यूज करते हैं ना एफएक्स सब्सक्राइबर कार्ड, उसके फेलियर ज्यादा आते हैं।
सब्सक्राइबर कार्ड का पुराना हमारा अराउंड 2008-9 तक का जो एडेप्टर था, शायद उसका बाद में उसमें कुछ फेलियर हमने ज्यादा ऑब्जर्व किए हैं। बट अभी करंट जो हमारा सब्सक्राइबर कार्ड आ रहा है उसमें एटलीस्ट फ्रॉम द लास्ट 5 years सिंस 2015 हमारा जो सब्सक्राइबर कार्ड है उसमें तो ऑलमोस्ट मतलब फेलियर ऑलमोस्ट नील है। Okay, so if you have a old card, then maybe you are facing some issues. But I don't think if you are new, a card made within the last 6 years will not be facing such issues, as far as my experience.
अच्छा, कुछ क्वेश्चन सर इन्होंने चैट बॉक्स में भी पूछे हैं, आप देख लीजिए थोड़ा उनको भी।
हाँ ठीक है, हम देख लेते हैं। अच्छा, in the extra jumpers E6 अगर E5। अच्छा, ये मैं एक क्वेश्चन मैं देख रहा हूँ रिगार्डिंग सम जंपर सेटिंग। अच्छा, सब्सक्राइबर चाइल्ड का जंपर सेटिंग मैं एक बार दिखा देता हूँ आपको फिर। हाँ, सब्सक्राइबर जंपर सेटिंग ना, शेयर कंटेंट। शेयर तो होती है। স্লাইড দেখা যাচ্ছে? আসছে? মিটিং Yes. This is the. Can you see this slide? This is the subscriber hotline adapter. You can see the jumpers that need to be set. They are circled. Okay, the first two jumpers, the top two jumpers, you do not need to change their position. The other 5 jumpers only you need to change the position. Okay. In case of hotline, yes, voice also is the same. There are 4 jumpers in case of voice channel. Okay. In case of hotline, and also in case of subscriber hotline, whenever you are checking, you make sure that when you are lifting, in case of subscriber, when you are lifting the telephone at one end, you make sure that the M lead is glowing at your subscriber card, and at the exchange end also E lead should be glowing. Make sure that you get that. Get RBTS station A. So there is one question. If we leave handset at station A, we get RBT at station A, and ring at station B. But if we leave handset at station B, no RBT at station B and no ring at station A. In this case, the at station A only the mother card of the hotline, that is that you need to change. That is not working properly. This question from Mr. Hara Rao. Okay. If we leave handset at station A, we get RBT at station A. This question at station A, your mother card needs to be changed. The voice mother card needs to be changed. That has become faulty. In case of baby card defective, we can defective. One thing we do is if they are in warranty, we can if we can of course get them repaired. But out of warranty cards, you will have to. We can repair it in on a payment basis. We repair our cards to third party or directly also sometimes. In case of faulty cards, whatever modules you have, you can contact us for repair. If they are within warranty, then no issue. You can just send us the card with a letter, and we can arrange to repair them. In case of out of warranty cards, it would be better if you come through the agency that has supplied you the material. We can arrange to repair them, repair it through payment basis. Subscriber and hotline card jumper setting, I think there should be no issue. Other than these 5 jumpers in subscriber and hotline, no other jumpers need to be changed. Okay, I'll forward the PPT, no problem. And I'll also forward a few other documents as well. So, please explain. RxF alarm observed NMS. This RxF alarms, 64 kbps alarm is sometimes that is an issue that we have observed, but it's not a major issue. It's there are some issues with the NIM card probably for which it's generating the alarm. Then internal and external NMS, we always keep our NMS in internal mode for STM. External NMS was used when we had a separate OLT. We had to connect it the NMS to OLT. We had external NMS. You always have to keep the NMS in internal mode. In case of DC voltage monitoring is shown wrong, then the calibration of NMS of NIM card has to be done once again. Okay. Okay. Any other questions? I'll share a few more documents with you. I'll share a few files which contains the our training manual and a few other things, checklist and all those things it contains. Among the files I have shared, there is a manual for our training manual for our MUX, as well as few other documents. So one of the things I'll show the loop protection module. Okay, if there are no more questions, then I think it would be. Should we conclude this session? Okay, so we shall we conclude this session then today?
हेलो सर एक और क्वेश्चंस आया है शायद चैट बॉक्स में।
हाँ बोलिए।
ये बोल रहे हैं कि सर इफ एनी स्टेशन डीसी वोल्टेज मॉनिटरिंग shows wrong, what will be the issue?
That I've already discussed. That is the calibration needs to be done. The calibration of NIM card needs to be done. It cannot be done in the site. It has to be done in the factory itself. So if DC voltage monitoring is showing wrong, then I think you have to. If it's other functions are fine, then I think it should be left as it is. Also, if you need it to be corrected, it has to be corrected in our factory only. Okay. And I have shared some documents. I think if you can download them, it will be helpful to you. Which I have. Disadvantage and advantage. It's of enabling and disabling switching, remote switching table at intermediate sessions. See, if in intermediate sessions, if you keep the remote table switched, then when there is a failure and all the tables do not switch at a single instance, right? It takes some time. So sometimes, especially if you have a longer network, say of 20 or 25 stations, you can have a noise in the control channels for persist for about up to 30 seconds. So if you do not need the remote table switching at intermediate stations, it would be best to keep it switched off. Okay. And does it affect auto protection? No, remote table switching does not affect auto protection. Auto phone you cannot actually protect using the ring protection scheme. You need a completely separate time slot for protecting auto phone. So normally it's not done. Remote tables switching at intermediate stations only affects if you have a semi-conference type cross connect. Okay, if you have a only conference and linear cross connect, remote table switching disabled will not affect your functioning. It will improve your performance. It will reduce noise during switching. Only if you have semi-conference cross connect, in that case only you need remote table switching at intermediate stations. Okay. And autophone or any other type of cross connect, remote table switching does not, disabling remote table switching does not affect the circuits. Okay. Okay. Any other questions? I think we should should be able to conclude it. If you have any individual email ID for further information, okay, I'll send share my email ID. Can communicate with us in either of these email IDs. Okay. And if any specific questions are there or any specific assistance you need, you can always call any of us at any point, anytime. Okay, no problem. Okay, so shall we conclude this meeting?
Okay, sir.
Okay, okay. Thanks. It was a pleasure.
Thank you, everyone, to connect with us. I hope all you get more information about your WEBFIL MUX. ठीक है देवदत्त जी, अब जो है कंक्लूड कर दीजिए.
Okay, okay, all right.
Thank you all.
Thank you, everybody.